Hello students, I hope you are already gone through the PDF which I have already uploaded into Google Classroom. I am starting from Unit 4. The topic is Logic Gates. I will prepare a mini lectures. Most of the description is given in the PDF. So let's start with the first topic, Logic Gates. Logic gates is the digital circuit with one or more input signals but only one output signal is called a logic gate. Here one switching circuit shows. So if we apply the possible combinations between two switches, like first switch is open, second switch is open, the bulb is off. First switch is open, second switch is closed, bulb is off. First switch is closed, second switch is open, bulb is off. And if both switches are closed, bulb is on. So in the logic circuits, there are possible output is only one, on or off. There are two possibilities. There are two possibilities, but the output only one, off or on. So off is considered like low, on is considered like high. Low means 0 volt and high means positive 5 volt. If we converted this possibility into the truth table, so this is low or the 0 output is 0 volt, 0 1 output is 0, 1 0 output is 0, 1 1 means high or the positive plus 5 volt, output is high plus 5 volt. There are three basic logic circuits: OR gate, AND gate and NOT gate. A binary 0 represents 0 volt and binary 1 represents plus 5 volt. It is common to refer to binary 0 as low input or output, and binary 1 as high input or output. A logic gate has only one output signal. The output will depend upon the input signal or signals and the type of the gate. The operation of logic gate may be described either by truth table or Boolean algebra. First one is OR gate. So here you can see the circuit of the OR gate. Two input and one output. So let's apply different conditions. If A and B are connected to ground, then both diodes will not conduct it because it's reverse bias, right? So diode D1 and D2 will not conduct and your output will be 0. In terms of binary, 0 plus 0 is equal to 0. If A is connected to ground and B is connected to positive, then diode D1 will not conduct current, but diode D2 will conduct current. So it will conduct current and output will be positive plus 5 volt. In terms of diode D2 is forward bias, that's why it's conductor current, and you will get the output positive plus 5 volt. In terms of binary, it will be 0 plus 1 is equal to 1. Similarly, if A connected to positive but B connected to ground, the diode D1 will forward bias and conduct current, and you will get a plus positive 5 volt. In terms of binary, 1 plus 0 is equal to 1. If both A and B are connected to positive, then both diodes are conduct a current and output will be positive plus 5 volt. In terms of binary, 1 plus 1 is equal to 1. It means the OR gate is if all or any input is high, the output will high. The symbol of OR gate is this. The Boolean expression for OR function is A plus B is equal to Y output, and this is the truth table. 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1. So from the truth table it is clear that the OR gate, the output is high if any or all the inputs are high. If any or all the inputs are high, the only way to get low output is by having all inputs low. If you put all inputs low, your output is low. So this is the OR gate. Next one is AND gate. So this is the digital circuit for AND gate. If you apply the same conditions here, if A, here you can see this is the direction is changed of the diode as compared to OR gate. If A and B are connected to ground, if A and B are connected to ground, it means the diode D1 and diode D2 will forward bias, because this is negative, this is negative, this is positive, this is negative, and this is connected to ground. So it is D1 and D2 both are forward bias and conduct a current. So current will flow from like this from both the diode, and your output will 0. If A connected to ground, B connected to positive, then diode D1 is forward bias and conduct a current, whereas diode D2 will not conduct a current. Since it's conduct a current from like this, your output is 0. In terms of binary, it is 0 multiply 1, 0. Another condition, when A is connected to positive and B is connected to negative, your diode D1 not conduct, but diode D2 will conduct. So current will flow like in this direction, and your output is 0. In terms of binary, 1 multiply 0 is equal to 0. If both are conducted to positive, so both diode will not conduct a current, because if it is connected here, then it will be reverse bias and not conduct a current. If both the diodes will not conduct a current, the current is only from here, it will not conduct a current, so you can get a plus positive 5 volt. In terms of binary, 1 multiply 1 is equal to 1. So this is the AND gate, and the symbol of AND gate is this. Boolean expression for the AND function is a dot b is equal to y, and the truth table 0 dot 0 is equal to 0, 0 multiply 1 is equal to 0, 1 multiply 0 is equal to 0, 1 multiply 1 is equal to 1. And it is clear from the truth table that for the AND gate, the output is high if all inputs are high. Output is high if all inputs are high. However, output is low if any or all inputs are low. If any or all inputs are low, output is low. The next one is NOT gate, or we can also say the inverter. It has only one input and one output, where the output is opposite of the input. The NOT gate is often called the inverter because it inverts the input. The Boolean expression for NOT function is y is equal to a bar, and the truth table, if the input is 0, then output is 1. If the input is 1, then output is 0, and this bubble sign shows the inversion. Similarly, the bar sign, which is above input A, represent the inversion. So if A is equal to 0, then y is equal to 0 bar, or y is equal to 1. If A is equal to 1, then y is equal to 1 bar, or y is equal to 0. If we see the circuit of the NOT gate, so here you can see that RK and RB, resistance of the RK and RB are the divider of the logic circuits, and if A is input connected to negative potential, or A is connected to ground, then the base is goes to the negative potential, and your transistor is cut off, means off conditions. Your transistor will off conditions. So here the positive voltage you will get when A is ground, you will get the positive voltage plus 5 volt. But when A is connected to positive, or A is connected, or if we apply the voltage plus 5 volt here, then your transistor will on. Once this